People say a butterfly flapping its wings can cause a tornado on the other side of the world, which sounds impossible until you realize the real idea is even stranger. Butterflies are not secretly controlling the weather. The main idea is this: two starting points can be almost identical and still end up with completely different futures, as shown in the graph. That is known as the butterfly effect. A tiny difference at the beginning can grow over time until it becomes a massive difference later. To understand this, we need something called a differential equation. And I know that sounds intense, but the idea itself is actually simple. A differential equation asks, where is something and how is it changing right now? It's like the math giving objects driving directions. In some systems, small differences disappear. Here, both dots start in slightly different places, but they both get pulled towards the same point. This is a stable system. Tiny mistake? No problem. It gets cleaned up by the math. That is what we usually expect. If two things start almost the same and follow the same rules, we expect them to stay almost the same. That feels predictable, and that feels normal. But chaos walks in, kicks the door open, and says, actually, not always. For the butterfly effect, we are not just tracking one number anymore. We are tracking a whole state of numbers. Think of a system described by three numbers. Let's represent them as X, Y, and Z. Those numbers could represent parts of a weather model, or more generally, the state of something changing over time. Now, we give the system rules. Those are the Lorentz equations. And yes, I know they look like they were designed to scare people away from math, but do not panic. The idea itself is simple. These equations tell the point how to move. At every moment, they calculate the next tiny step for the object. Now that I've explained a little bit more about what chaos is, let's put it into action with this double pendulum experiment. A double pendulum is basically two pendulums attached to each other for reference. So, these two pendulums are 0.001 radians apart, and once we let go, we can see that their paths overlap and that the movement itself is almost identical. But when you least expect it, that is when the change happens. We can see a tiny difference start to grow, slowly but surely. Then, it starts growing faster and faster. The paths begin to separate, and suddenly, these two almost identical starting points are living completely different mathematical lives. And that right there is the beautiful part. The system is not random. It follows the same equations the entire time. But because the tiny differences grow so much, long-term prediction becomes almost impossible. While the future isn't just fully ruleless and random, it is extremely hard to predict because of such small margin of error. And that right there is why chaos matters so much in real life. To predict a chaotic system perfectly, we would need to perfectly measure the starting conditions. And in the real world, perfect measurement is basically a unicorn with a calculator. So, the butterfly effect is not magic. It is not randomness. It is what happens when a system follows precise rules. But rules amplify tiny differences over time. A small error, given enough time, can become a huge uncertainty. Chaos is not the absence of rule. It is the sensitivity to them. And that right there is the math behind the butterfly effect. I hope you guys enjoyed this video and found it very interesting.